Hello students. In this exercise, we are going to study how to get cumulative distribution function, CDF, from probability mass function, PMF. So getting CDF from PMF. Here's a reminder. The probability mass function is a probability where the random variable capital X is taking a numerical value small x. Cumulative distribution function is a probability that random variable capital X is getting numerical value small x or less. Or less. That's the key part. So we have cumulative probability. Here's an example problem. Let's suppose we have a probability mass function given like this, and the possible x values that the random variable can take is 0.5, 1.25, 1.75, and 2.0. Each one comes with a probability. The probability 1/4, 1/8, another 1/8, and 1/2. Please note that all these add up to 1 because that's the full probability. And then of course, other than those four numerical values, impossible, so the probability is 0. Now this part is not that necessary, and a lot of textbook authors just skip this part. Okay, let's go. First, let's begin with some color coding just to help us out. Just to help us out. So for the first possible value, 0.5, blue, 1.25, red, 1.75, green, and 2, 1/2. Okay, all right. And this is the graph of the mass function. We have four masses, blue, red, green, and brown, and the height corresponds to the probability. 1/4, 1/8, 1/8, and 1/2. At the x value 0.5, 1.25, 1.75, and 2.0. All right, that's a mass function. Now let's find the cumulative distribution function. And cumulative distribution function is the cumulative probability. Oops. Okay, over here. So let's find out cumulative distribution function. And cumulative distribution functions are defined for each interval, not at a value. Let's go back to the definition here. CDF comes with inequality, while PMF is for equality. So for PMF, we have probability at 0.5, at x equals 1.25, at x equals 1.75, etc. For CDF, we need intervals here. Okay, what intervals am I talking about? We have four numbers here, 1, 2, 3, 4. So those four numbers divide the number line into four pieces. Do I have the picture here? No, I don't want to give away too much right away. So okay, let me stop this recording and prepare some extra graphics here. Just a moment, please. All right, I completed the graphics and let's run it. Okay, this is the diagram that I wanted to show you. And that's why I stopped this recording. All right, we have four possible outcomes here. X value is 0.5, 1.25, 1.75, and 2.0, and we have appropriate probabilities there. That's the mass function. Now the mass function are for equations or equalities. Capital X is equal to something. Those are points. And those points correspond to these 4 points. 0.5, 1.25, 1.75, and 2.0. Not regarding the scale. Of course, if you draw up to scale, then the distance between these two are much shorter and that's larger, and then we don't have enough room to write down the inequalities here. So I disregarded the scaling and then just wrote down all these 4 points in equal distance there. And then let us mark the intervals. Here in this interval, x is less than 0.5. Second interval here, between 0.5 and 1.25. Next, between 1.25 and 1.75, and so on. So we have these four numbers, and these four numbers divide the number line into 5 pieces. 1, 2, 3, 4, 5. And for each interval, we have appropriate probability, appropriate cumulative probability, and that's something we are looking for. Okay, this was just copied and pasted from before, so all these numbers here, and none of them matter as a matter of fact. And then let's put appropriate inequalities here. Okay. All right. Next. And then finally, this. Okay, I just got these intervals up there in the diagram down to these. So this diagram here was just for explanation. Experienced students will go from here to there directly. We have 0.5, 1.25, 1.75, and 2.0. So less than 0.5 here, this one. And then between 0.5 and 1.25, between these two. Next, between these two, between 1.25 and 1.75, between red and green. And then between these two, between green and brown. And then right hand side of the brown. Okay, and then if you want to be even more specific, you can insert this one as well, less than infinity. You see, everything is less than infinity, so this part is not that necessary. So, excuse me, that part is not that necessary, so I de-emphasize that part in gray, but it actually helps. Okay, all right. Now that I got all the intervals right, or all the class intervals right, let me get the probabilities. So here, to the left of here, we don't have any dot, no mass. So the probability always begins from 0. Next, it's cumulative distribution, so you have to accumulate probability. You have to add something. Right here at x equals to 0.5, what's the probability? It's 1/4. I have to add it. Next, in this interval here, now I have two masses, blue and then red. I have to add them up. So previously I had 0 plus 1/4. I have to add the next probability, 1/8. This was there before. Now let's go to the next interval here. I have 3 masses accumulated thus far. So we have to add up these 3 probabilities. So start from the previous. And there you go. This was there before. That was there before as well. And this one's new. Now finally over here, all four masses are here, so I have to add up all the probabilities. 0 plus 1/4 plus 1/8 plus another 1/8 plus 1/2. And if you calculate everything right, you're going to end up with 1. So that's a cumulative distribution function. We begin with a mass function, and the mass function is given in the table form like this. Okay, all right. And I use color coding, but it's not really that necessary. If you know what you're doing, you can do this without color coding as well. But color coding helps me explaining this to the majority of the students. So I'll just use it. And if you understand better with color coding, then use some, I don't know, some markers or something to create your own color coding. And then look at these four masses, 0.5, 1.25, 1.75, and 2.0. Those four masses represent 4 points in a number line, as you can see here, blue, red, green, and brown. And those 4 points divide the number line in 5 pieces, 5 intervals. Less than the first, between the first and second, between the second and third, and so on. And at each interval, we need probability. We need accumulated probabilities, so or cumulative probability. In the first interval, nothing here, nothing to our left, so everything begins from 0. And then from the second interval, I have 1 mass, so I need 1 addition. Next interval, I have 2 masses, so I have to add up to here, and then add another, and then add another. So we have cumulative probabilities downstairs. Let me show you the answer key here. See, you do this computation, add up, add up, add up, add up, and then okay, all right. You have all these answers, 0, and then this 1/4, and then 3/8, 1/2, and then 1. And those are the function values. And if you represent it in a graph, you're going to get a step function like this, step graph. Up to 0.5 in the first interval, this one goes all the way up to negative infinity, by the way. The probability is 0. The cumulative probability is 0. So height is 0. Next, the height is 1/4. And then this jump is 1/4. And that's a mass function. That's a mass. And the next 1/8, excuse me, this is not 1/8. This was 1/4, and then I have to add 1/8, so we get 3/8 here. So the jump is the mass, the probability mass. And then another 1/8 jump, that's the probability mass. And then at 2.0, I have big jump, 1/2. And then everything ends at 1. That's the probability, excuse me, this is the cumulative distribution function. And the probability mass function, here we go, we have 4 masses, blue, red, green, and brown. And then we have x values, 0.5, 1.25, 1.75, and 2.0. And the heights are the probabilities, 1/4, 1/8, 1/8, and 1/2. Now, the cumulative distribution function, we have steps. Step, 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 step. And then at each jump, at each discontinuity, we have the probability masses. And let's include this picture. And this one's duplicate, so I don't need it anymore. And here's the whole problem.